Now that we've done confidence intervals for proportions, let's look at hypothesis testing for proportions. We know the first step for hypothesis testing is to state your hypotheses. So what do these look like when we're dealing with proportions? Before, whenever we did these, we had mu equal to some number, but mu was because we were dealing with a mean. Now we're dealing with the proportion, so instead we'll use p. So our null hypothesis will be p equal to some value depending on the problem. So I put a question mark here. Depending on the problem, we'll have our value. Our alternative hypothesis will then be that p is greater than, less than, or not equal to the same value. The second step has been to find the p-value, and we've been using a calculator to find this value for us. So how do we do this with the GeoGebra graphing calculator? The command on the calculator is going to be z proportion test. And in that we need to enter in our sample proportion, our sample size, this value for the null hypothesis, the value that p is equal to in h0, and the tail, either less than, greater than, not equal to. And finally, we need to make our decision. And just a reminder, if the p-value is less than alpha, then we say HA is true. That doesn't change for proportions. That's going to be the same for all of our hypothesis tests. So let's do some examples. An article states that 45% of people regularly attend church, but you think that number is way too high. A random sample of 200 people showed that 78 of them regularly attended church. So we want to test your claim with alpha equal to 0.05. So the first step is our hypotheses. This article is claiming that it's 45%, so that would give me my null hypothesis. P is equal to 0.45. You're claiming that this value is just too high, so the alternative hypothesis would be that it's less than 0.45. Since we're dealing with proportions, we need to use the z proportion test. The first thing we need is the sample proportion. And we see that 78 out of the 200 people attended church, so our sample proportion would be 78 out of 200. The next thing we need is the sample size, which is 200. The value for h0 is 0.45. And then finally the tail. This is a less than. And just a reminder that we do need to put that tail in quotation marks. So let's go over to the calculator and enter in this information. Here's my graphing calculator. I can hit the three dots. We scroll down to statistics. And then down to the z proportion test. It's the very last thing in statistics. The sample proportion was 78 out of 200. Sample size was 200. H0 was 0.45, and this was a less than, so we need to go to ABCs and the symbols to get the quotation marks. And then we can enter in the less than. So here the p-value is 0.044. We then need to compare that to alpha, which is 0.05. And we can see that the p-value is smaller, and when the p-value is less than alpha, then HA is true. So your claim was correct. This number is too high. For my next example, approximately 21% of Americans have at least one tattoo, and a researcher wants to test if this is accurate. A random sample of 150 people showed that 35 of them had a tattoo, and we want to test with a 5% significance. So we need to start with our null and alternative hypothesis. We're claiming that out of the population, 21% have at least one tattoo, so our null hypothesis would be that p is equal to 0.21. The researcher isn't claiming that this number is too high or too low, so the alternative would just be that it's not equal to 0.21. Since we're dealing with proportions, we need to use the z proportion test. The first thing we need to enter is the sample proportion, and we had that 35 out of this 150 had a tattoo, so 35 over 150. The sample size would then be 150. We then have our value for h0, which is 0.21. Finally, we have the tail, which is not equal to. And once again, we need to put it in quotations. So now that we have that, let's move over to the graphing calculator. I'm going to click the three dots, the z proportion test. The sample proportion was 35 out of 150. Sample size is 150. H0 is 0.21, and my tail was not equal to. So we have a really high p-value, 0.48. And we can see that this p-value is significantly higher than 0.05, our value for alpha. And since the p-value is bigger, we go with H0, that it is actually 21%.